Hello, this is instructor Rick Powers from Western Technical College, Basic Statistics. Lesson 32, Hypothesis Testing, Classical Example. We will now do an example of hypothesis testing using the classical approach. Consider this situation. A recent study found that concussions were 11% of the injuries of college students on equestrian teams, horse riding, based on 568 injuries. The NCAA reports that 7.4% of all college football injuries were concussions. Is there evidence that the rate of concussions for the population of equestrian teams is higher than the rate for football teams? Use alpha equals 0.05. Note the direction of the comparison is consistent with the fact that the sample number, 11%, is higher than the standard number, 7.4%. Determine the hypotheses. The sample information gives us 11%. We're comparing that to 7.4%, which is not from a sample, but is given as a standard number. So the hypotheses are the null hypothesis, p is equal to 0.074. The alternative hypothesis, p is greater than 0.074. Note the number is the same in both hypotheses. The null hypothesis has an equal sign. The alternative hypothesis shows the direction of the comparison. Also note the letter P in these statements represents the population proportion of concussions on equestrian teams. We start by assuming the concussion rate for equestrians is the same as the standard number from football, and we want to prove that the rate is actually higher for equestrian teams. Calculate the test statistic or the test value. Here's the formula for Z. Z is equal to p hat minus p0 divided by the square root of p0 times 1 minus p0 divided by n. Note that p hat is the sample proportion. P0 comes from the null hypothesis, and n is the sample size. In this case, 0.11 minus 0.074 divided by the square root of 0.074 times 1 minus 0.074 divided by 568 comes out to be 3.278. Technology will also work for this, but may have differences due to rounding. Next, find the critical value. We have alpha is equal to 0.05 on a right-tailed test. Since we're dealing with proportions, we need the z-score for a right-tailed area of 0.05. Technology will tell us the critical value is z equal to 1.645, so the rejection region is z greater than 1.645. Big idea. If the test value is in the rejection region, then we reject the null hypothesis. So, since the test value is in the rejection region, then we reject the null hypothesis. We can say with 95% confidence, there is evidence that the population proportion of concussions as a percentage of injuries is higher for equestrians than it is for football. This was our goal, to prove a difference. Is this important? Does it have practical significance? We don't know, since we are not sports science experts. You can also use Google to see articles about it. Rugby also has high concussion rates. Let's look at another example. What if we had 12 concussions out of 100 injuries in women's ice hockey? That is the sample proportion of 12%. What conclusion would we draw? Use alpha is equal to 0.05. The hypotheses are the same, and the critical value and rejection region are the same. The test value, though, is 1.375. Since our sample size is smaller, then our sample number is going to have less accuracy. The difference between the sample and the assumed population number might be due to chance. The test value is not in the rejection region, so we do not reject the null hypothesis. Therefore, we do not make a decision. The difference could be just a random event. We say with 95% confidence, there is not enough evidence to prove that the population proportion of concussions as a percentage of injuries for women's ice hockey is greater than the rate for football. Did we measure a difference for women's ice hockey? Yes. In fact, there's more of a difference for this sample than the previous example. However, due to small sample size, we cannot prove that the difference is statistically significant. End of lesson 32.